Now what we do for AC operating condition, we remove DC sources and short circuit the capacitors. So in this, what will be the change? This capacitor will be shorted, this capacitor will be shorted, and this voltage source will be removed, that is grounded. So how the circuit will look like? The circuit will look like this. You have RE, RB, RS, right? VCC is grounded, the capacitors are removed. So the circuit will look like under AC operating conditions, the circuit will look like this. Now what we need to do is, we just need to replace this transistor with the hybrid pi equivalent circuit. Rest of the components will remain as it is. Now the hybrid pi equivalent. This is how we have reduced RB, RS. R pi is between base and emitter but towards the base. Then GM pi is between collector and emitter, right, but towards the collector. Since early voltage is given, we need to write RO, RE, right. Similarly, we have done for the problem, we have found all these values from the DC analysis. Now how to do the analysis? First we need to find the input resistance. For this, now if the current source is open circuited, the circuit will have RS, RB, then R pi. This current source is open circuited. For finding the total resistance, you have RO, you have RE. So these resistances are not now redundant, so we need to consider these resistances in order to find the ZIB. In previous cases, since the current source was getting open circuited, the resistance were getting redundant, but in this case they are not getting redundant, we need to consider them. Now considering this part of the circuit, which is redrawn over here, RB, R pi, RO and RE. Now we need to find the current through it. When you apply KVL in this loop, what you will get? VI, we are living with positive sign, then positive negative, so minus IB into R pi minus IE into RO parallel RE. That means what I am doing, instead of these two resistance, we can write a single resistance RO parallel to RE. Instead of drawing these two resistance, I can show a single resistance, so we can write this equals to 0. Now I can express IE as IB plus IC. IC can be written as beta IB, so I can write IE as 1 plus beta times IB. So when substituting this part over here, what you will have in the equation? VI minus IB R pi minus 1 plus beta IB into RO parallel RE equals to 0, right? If I am taking all these terms on the other side, I will have VI equals to, and taking IB common, I will have R pi plus 1 plus beta times RO parallel to RE. Now what is VI upon IB? When you see, VI is the voltage upon the current, that is nothing but the resistance ZIB. So I can call ZIB equals to VI upon IB, which is because the current flowing is IB and voltage between these points is VI. When you consider this entire thing as a single resistance, right? VI upon IB, which is equals to R pi plus 1 plus beta RO parallel RE. This is how we have found the resistance ZIB. Now once we have found ZIB, the circuit is reduced to this. Instead of R pi, RO, RC, that is all of this are considered in ZIB. Now what you can say ZI is, when you immediately look at the diagram, you can call RB is in parallel with ZIB, so that is nothing but your ZI, right? Now can you find RI, that is the total resistance Zin? How we can find total resistance? By potential divider rule also we can find. This is RS, this is your RB, this is your ZIB, this is VS, and the voltage is nothing but VI. By potential divider rule also you can find. Now when you are reducing this as in the networks or BEE, you have RS, and instead of ZIB I can write a single resistance RB parallel ZIB. Now both are in series, so current will be the same, so I can call Zin is RS plus ZI, which is ZB plus ZIB, right? So in the shortcut manner you can find the value of the resistance. Now how to get the value in the problem? You know all the values of the resistance, R pi, 1 plus beta, RO, RE, everything is given in the question. So after substituting the values, you should get ZIB as total value of the input resistance seen from the base is 119.65 kilo ohms. Once you know ZIB, you can find ZI, that is RB parallel ZIB. RB is nothing but RTH, so this will give you 14.62 kilo ohms, right? And once you know this, just add RS, which is 0.5k in this, so you can find ZD, right? That will give you 15.12 kilo ohms. So this is how we have done the analysis for the input resistance. Now we go for the output resistance.